This video file was recorded in Sabunja University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Hello guys. Last week we played the Tic-Tac-Toe game, if you remember. We are going to do it again. Again, we are going to divide the class in 3 parts. At the first part, we are going to do the Tic-Tac-Toe game again, and we were asked to repeat it because it is related to your homework. Then we are going to see some number representations, how the computers represent the numbers, how they keep the numbers, record their numbers, and some bitwise operations. Okay? So let's start with the Tic-Tac-Toe game. Just let's add the codes. Tic-Tac-Toe and everything related to the Tic-Tac-Toe. Please pay attention, because something similar is going to be given to you as a homework. As a matter of fact, your homework has been already assigned a week ago, and you have like 4 or 5 more days to do it. But of course, I'm pretty aware that most of you even didn't see the homework, because it's not the deadline. Okay, so for those guys that didn't play the Tic-Tac-Toe, for those that are watching the video, or for those hardworking guys that when they were in primary school they didn't play games, they only used to study, just let me explain to you what it is about. Well, it's kind of a scheme, a matrix with 3 rows and 3 columns. We have 2 players. One player has the X character, the other one has 0 or dot, whatever, and they take turns. Okay, one player puts his corresponding character anywhere in this matrix, if it's an empty place, and then the other one does it. If a certain player manages to horizontally put consecutive 3 characters, or vertically, or diagonally, then he or she wins the game. So let's say if I have something like this. X, 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 no matter about the zeros or O's or dots, this guy wins. I can win if I have something like this, X, 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 so the guy wins. So horizontally, vertically, and 2 diagonals, there are 8 cases when you can win. Okay? So let me play the game again with you here, just to refresh your memory, and then we're going to go through the codes again. I want a volunteer that is going to lose. Last week, if you remember, your friend lost. And I want another one to play with me that is going to lose the game. Come on. Don't force me to do the job of United Airlines here. A volunteer. I'm asking for a volunteer. Don't be afraid you won't lose points. You want to play. Okay. I'm warning you, you are going to lose or at least draw. Okay. Let's do it. So, I am X, you are 0, and I'm starting. I want to put, by the way, we have 3 rows, 3 columns, just as it's in an ordinary matrix. Rows and columns are numerated starting from 0. Okay, 0, 1, 2, 0, 1, 2, for the rows and columns corresponding. So 2, 2. What's your move? 0, 0. Okay, nice try. 0, 2. Congratulations, you lost. By the way, I'm telling to you from now. Your turn. 1, 2. What do you think? What I'm going to play now? This is called game theory. When you take your moves, you try to beforehand get what I'm going to do, okay? What I'm going to play what? 2, 0. Yes. I'm going to do that, of course. So your turn now. 1, 1, okay. And this is it. So I won. I'm sorry. I warned you about that, okay? This is called game theory. When you take your moves, you will assume that my next move will try to improve my situation, okay? It's very hard stuff that was done like 30, 40 years ago, and it has a lot of implementations in computer science. So if you're going to be a computer scientist, you will deal with theory games a lot. But it's not a matter of concern here. Just let us see how did we do this crap. How did we come up with this game? Let's start with, so we have two headers and two corresponding CPPs. We have two classes, the board and the player class. Let's go with the board class. And then we'll go with the main function, where actually we use what we have already implemented at the board and at the player class. So this is class board. I'm writing it. For those guys that just came, pay attention to this example. We are doing it again this week, since this is going to be related to your homework. Try to understand it. It will be very similar to your homework. Just your homework will be a bit harder than this one. So, as private data, we have the board itself, which is a matrix of 3 rows and 3 columns. So, the name of the matrix is my board. And I'm going to write it here. So this is the board. I also have another function which is called cell is empty, returns true or false. So this is my class board. Those are my private data, my board, and cell is empty. Cell is empty. Okay. What do we have as public data, public functions? The board, the constructor, of course. What else? Play on board. As you can see, it returns a boolean, true or false. We will see what it's doing. Then we have check someone wins. Check someone wins. What else do we have? Display board. This is for printing the board. And is board full? Is board full? The names are self-explanatory usually, but we'll go through them. Anyway, let's see now what are those functions about. Let's go to the corresponding CPP file, board.cpp. The constructor, this guy. Well, as you can see, when we declare a variable of class board, we make everything here to be empty. And what do we mean by empty? We mean that everything inside this cell has an underline, which means that the board is empty. The cell is empty. The square inside the board is empty. If we have this underline, it means that it is empty. We have the function cell is empty also, so we saw the constructor. Cell is empty is a private member function. What it is doing, it returns a boolean. Let me find it. So here it is, and it checks. If it takes as a parameter the row and the column, and it checks whether the corresponding row and column, the box with the corresponding indexes for the row and the column, is empty, meaning if it's underlined. If it's underlined, it returns true, otherwise it returns false. Okay? So it takes 2 parameters, the row and the column. Of course, rows and columns are enumerated as it is the case in an ordinary matrix. Let's go on with other functions. Play on board. This function. What it is doing. As a parameter, it takes the string, and the string is going to be usually x or 0, as we saw it. It takes the row, the index, and the column. And it tries to put the character to the corresponding place. Of course, if we try to put something outside the borders, row 5, column 6, it's undoable. That's why we check whether the indexes are inside the boundaries, meaning the row and the columns corresponding, both of them should be greater or equal to 0, smaller or equal to 2, in this range. Furthermore, we check whether the cell is empty. Because let's say, if one player puts his string or her string here, and someone else is trying to put his string also here, we should not allow it. Okay? That's why we should allow it only when we are inside the borders, only when the cell is empty, and this function we saw it. Okay? We're using cell is empty, which was this guy, the parallel function. So if we are inside the borders, and if the cell is empty, where we want to put our character, then very nice, put the character, the string, which is the character x or 0, and return true. That means that we've successfully played a move. Otherwise, if you're outside of the boundaries, then we'll print that this cell is not valid, invalid move, try again. Or, if you are inside the boundaries, but the cell is not empty, this cell is not empty, invalid move, okay? So if the cell is not empty, this is going to return false, and we will print this guy. This is all about play on board. Let's go and see display board. This function is doing nothing else. It's kind of a trivial function. It prints the board. Okay, this guy. Prints the matrix, basically. Check someone wins. How do we check that someone wins? Let me emphasize this part first. I'm going to make it smaller. So, we check whether we start with this if. We have the index 0, 0, 0, 1, 0, 2, which is this part here. 0, 0, 0, 1, 0, 2. We check if the same character is here. Or, okay, you remember when does the player win? If horizontally, vertically, diagonally, he has the same character. Okay? If we have the same character in any of those horizontal lines or vertical or diagonal, that particular player wins. So we check. And I forgot to tell you that this function as a parameter takes the character, x or 0. So, with this part here, we check for the horizontal line. Then with this part here, if this is not true, then we go here. We check 1, 1, and 2, 2, which is this one, the diagonal. Then 0, 0, 1, 0, 2, 0. We check this part here. We are done with 3 combinations. Furthermore, we check this one, 0, 1, 1, 1, 2, 1. 0, 1, 1, 1, 2, 1. It's this part here. Furthermore, we check for 0, 2, 1, 2, 2, 2. So we are here now. 0, 2, 1, 2, 2, 2. So this part is checked. Then 0, 2, 1, 1, 2, 0. 0, 2, 1, 1, 2, 0. This one. And what is left? Only this line here, which is, no, 2 lines actually, 3 in fact. 2. 1, 0, 1, 1, 1, 2, which is 1, 1, 0. Let me check it. Row 1, column 0. This one. 1, 1, and 1, 2. So, yeah, we check for this horizontal line. And finally, we check for 2, 0, 2, 1, 2, 2, which is this line. Yeah, it looks kind of messy, but we check all the possible combinations for someone, for a certain character, whether he or she has won. So this was the function, check someone wins. We are going to do something similar in your example also, but it will be a bit more complicated. Is board full? What is this function doing? What do you think? Any idea? It explains itself basically. Well, we check all the cells whether they are empty. And if only one cell is empty, we return false, because this function returns true only when the board is full, meaning I've put x's or zeros in all of those places here, in all of those 9 cells. Okay, why do we need that? Well, if we have X's and zeros all over the board and no one has won, that means the game is a draw. That's why we need it. Only if one cell is empty, we return false, meaning that the board is not full. So this is board full. And finally, no, this is it. So this was all about the board functions. We have everything inside here, everything we need. So when we go to the player class and to the player member functions, it will be straightforward. So let's see what are we doing here. Let's say that we have not defined this with pointer, this macro here, this variable here. That's why we're not everything, if everything that is going to be evaluated as false by the preprocessor is not going to be compiled. So let's see what the class player is doing. First, let's see its private data and what's interesting about it. Well, as a private data, we have a reference to a board. And this is important, because this board here, we use it as a reference, and I'm going to emphasize it, because this is the most important part. And we call this board board. The name of this variable here is called board inside the player class. And this is a private data. So this is our class player. So this is my player class. Private members are this board, a reference to that board, and a string which is called play character. Let me put it here. So play character. This is a string. This is private. I'm going to write the public part here because we don't have place for that. Okay. So this is private, this is public. This is all class player. What do we have as public members here? We have the constructor, of course, which is called, has always the same name as the class name, player. We have another constructor. It takes two parameters, my board and a string, a reference to a board parameter called my board. And we're going to use that. So player, another constructor. Actually, this is done here. It sets the board, which was the private part, to be my board, and the character to be C. We have play and wins. Play and wins. What do those guys do? Straightforward. Let's go to the player CPP file. And let's see that the play function is doing nothing else but returns the value. So play uses board point play on board. So this guy uses this function. And the value that play on board returns is also returned from this function here. So if you remember, play on board plays here. It checks whether the boundaries are okay, whether the cell is empty, and we put the corresponding move. That's why we give the player string, which is this one, player character as a parameter, the row and the column. Wins. It also uses the function from the board class checksum on wins. So this is our function wins, and it is using checksum on wins. Everything is explained about the player class. Okay, now let's go to main, and let's see why do we need this object sharing. So, in main, we are going to use only references. We define two players, player X and player 0. Before that, we defined a new variable of type board, of class board, called myBoard. Basically, we created this board here, which is called myBoard. Then we declared two variables of type player, player X, player 0. We use this constructor here. But you remember, this myBoard was a reference. Okay, so when I created player X, let's say this is player X. This guy was inside, so I'm circling it. When I create the player Y, and I set this myBoard to be also inside, we have something like this. We have another object. Let me write it like this. Okay, but this player char will no longer be here. It will be here, player char. Of player X. So we have another object which is called player Y, and they both share this guy here. Okay, and it's a private part for both of them. Of course, outside those boundaries of the player X, we have the what? The player character. So, they see the board, but they don't see anything else. This player character belongs to player X. This player character belongs to player Y. And of course, this player Y, those are the private parts. Okay, this is private. And public, of course, it has the same those functions, which I'm not going to repeat. Okay, so if one of those players makes a change here in this board, the other one can do it. If this player makes a change in this board, player X can do it because they share it using references. So this is the most important part here. Now, if you remember, we defined a macro here, variable, which was called WITHPOINTER. Why did we do it? There are two ways to share a variable between two objects. One of them is references, as we saw it. Another way is the following. This board here has its address. Let's say the address is 1000. I'm making the number. Okay? So as a parameter, I can give the address of this board, this pointer, to both the player X and player Y. But when they access member functions here, they do it in this manner. You see? So instead of having a reference, I take an address, okay, and then those players, when they access members, they don't do it board point blah blah blah, but they use the arrows, okay, which is same as saying star board point blah blah blah. Okay, but since pointers are kind of tricky, I urge you not to use them for your homework. The best way to share a variable is using references, as we did it here. Now let's go and explain the remaining part of the main function. If you understood this, everything should be clear. So any questions till now? No. Let's go. We've declared player X and player Y. For the player X, my character is X, player character. For player Y, the character is 0. And we put them here. Of course, they share the board. Now, I start with row 0, column 0. And initially, it's always the turn of the X. This is how the game works. We have two Boolean variables, continue game. It will be always true if we can continue the game. And what do we mean by continuing a game? Well, or when this is going to be false, if someone wins, that continue games will be false. We don't have to continue anymore. Or if the game is finished, it's a draw, continue game will be false. Valid move actually will be the value that is returned with this play on board. If we try to make a move outside of the boundaries or put something in a cell that is not empty, valid move will be false. Okay? So initially it's false. In this while loop, we repeat it up until this continue game is going to be false. So we start and we ask, is it the turn of the first player? If it is the case, the first player is asked to give his rows and columns for his play, and we play it using the play function, this one, which in turn uses the play on board function. If you remember, this function returns a Boolean value. If the move was valid, it returns true, otherwise it returns false. So the return value will be assigned to this valid move. The same applies if the turn is for the player 0. And finally, we check. If previously we did a valid move, that means that we put the corresponding character on the board. And if it was the turn of X, then it's going to be turn of Y for the next iteration. Otherwise, if it was the turn of 0, it's going to be turn of X. But if this guy valid move was false, this is not going to be executed, so the same player will have the turn up until he gives a valid move. We display the board. We print this board here. And we check whether any of the players have won using this function wins, which in turn uses check someone wins. This applies also for player Y. If one of them wins, continue game becomes false. We also check whether the board is full, meaning whether it's a draw. If it's a draw, continue game is also false, and we print the corresponding messages, namely if it's a draw, if the board is full, we print that none won the game. If 0 wins, player 0 wins, we print it. If player X wins, we also print it. And this is repeated in this while loop. If continue game becomes false, then we go outside, and this is it. We say game is over, we display the board. Is this clear? Yes or no? Any question? Now, why did we go through this guide? Because you have a homework, which is due to, I think, Tuesday, yes. Meaning that you are going to upload it at 8:55 probably. The name of the game is Mill Game. I've never played it before. This is the first time I've encountered it. And it's very similar to this one. So, let me play it. Choose two characters. I'm going to choose X and O. We have 4 by 4, a matrix of 4 rows and 4 columns. Now, player X, please enter the coordinates where you want to put a piece. Let's say I'm choosing 2, 2. And I have my coordinate here. Now it's the turn of 0. 0, let's say, chooses 1, 1. We put 3 pieces of our corresponding character. Now it's player X's turn, and let's say player X chooses 0, 0. Now it's player 0's turn, let's say the guy chooses 5 and 5. Which is not okay, because we are outside of the range. That's why we get a corresponding message. Out of range, try again. Well, I'm going to choose 0 and what and 1. 0 and 0. It's not going to be a move, correct move, because we have a character here. You see 0, 0 is already, it's not an empty. Yes. Cell isn't empty. Choose a different one. Very nice remark, by the way. So let me choose 0, 1. Yes, I can do it. Now it's player X's turn, and player X chooses, let's say, 2 and 3. And it's now player 0's turn, and let's say that this guy chooses 3 and 1. Okay. Now when does the game terminate? If this guy manages to put this X here, then it terminates. Meaning if we have horizontally, yes, and vertically, if they're close to each other in consecutive cells. The 3 of them, all of them, but not diagonally. Only in horizontal manner and vertical one, okay? But not in diagonal manner. So how are you going to do that? Now, players take turn and they move their corresponding characters. But when they move it, they cannot move it, let's say, from here to put it here. They move only one step, moving in neighboring cells. Only one step. So let's say this X come here, then here, then here, okay? Or this 0 can go here, right or left, but not diagonally. So it's X's turn, and let's say X tries to move. First, when we try to move a character, we choose which one are we going to move. Now I'm choosing this one, which is 0, 0. And I'm trying to move it to this row here, to this place, to this cell here, which is row 1, column 0, 1, 0. And I moved it, okay? But no 1, 1. Now this is 0's turn, and I don't want to waste your time. If I move this guy here, then we will have in 3 vertical neighboring cells, consecutively, the same character. So player 0 is going to win the game. So I choose this character, which is, which one? 3, 1. And I move it to 2, 1. Okay. Congratulations, player 0, you are my hero. Player X never stood a chance, which is not true. Okay, so this is the mill game. I think it's much more complicated than as we have shown here, but we have simplified it for you. What should you have in your implementation? This is what you should have. Okay, so this is the game. Let me go to the classes. You should have the board class, just as we saw previously. Okay, we have 4 rows, 4 columns. You have a constructor, display board to print the board, just as is what it was the case with the Tic-Tac-Toe. Put piece to put X or 0. Move piece to move it, but be aware when you move it, you cannot move it in diagonal manner or in a cell that is not empty. You should move it in a cell that is empty. If it's not empty, you cannot move it. So you move right, left, down, up and down. So this is the move piece function. We didn't have it here, but we have, you will have it in your homework. Game over, and you should check whether the game is over or not. So this is about the board function, this one here. Of course, you're going to have the player class, and the player class, as you see, must share a board object using object sharing concept, meaning you should use reference variable or whatever. What do the player class have? They have the constructor, just as we saw it previously. They have the put function, and put function, let's remember the play and wins, should use the function from the board. We have the move function, and move function should put the function move from the board that we previously defined. In this case here, not here. What else the player function, player class has is winner and get symbol. Is winner, checks whether the guy has won or not. Again, it's going to use the wins function of the board that we have defined here for the mill game purpose. Get symbol, you just return the character, this character here, which was private, so get symbol returns it. This is it, nothing else. Any questions? Of course, in main CPP, I think main will be given to you, or no, it shouldn't be given. It is, but even if you don't, it's not given to you, it's easy to write it. So this is what you should do. If you understood the Tic-Tac-Toe game, you will not have a lot of problems with this game also. Any questions? Yes or no? Okay, well, I'll give you a break of 2 minutes. We'll be back. Not more than 2 minutes.